Once again, a warm welcome to the Nemetschek Build the Future ALLPLAN Summit. We already had a fantastic day one, and today you can again look forward to an interesting and inspiring program. You have the option to watch 19 sessions across 3 streams covering the life cycle from architectural design through engineering design to construction planning. And these are our 3 streams of today. Stream 1 is our architectural design stream, where you can stay up to date with all the latest ALLPLAN innovations and expand your skills with new time-saving design techniques through a range of online sessions on architectural themes suitable for all AEC professionals. Stream 2 is our engineering design stream. Here you can increase competitiveness through new engineering technologies and learn how the latest road and bridge solutions enhance productivity by a range of online sessions on engineering themes suitable for all AEC professionals. And Stream 3 is our construction planning stream. Learn how to take advantage of increasing prefabrication in construction and how to implement BIM to field in practice. Take a look at the online agenda to see what's coming up and plan your viewing.
Welcome to the presentation from architectural design to analysis and detailing, the workflow with ALLPLAN, SCIA and FRILO. First, a brief introduction of myself. My name is Maximilian Nemandi and I work as a consultant and pre-sales engineer at ALLPLAN. Next, I will briefly discuss the merge of ALLPLAN, SCIA and FRILO and introduce the programs individually. After that, I will delve in the cloud-based Open BIM workflow. Finally, I will summarize the content once more and highlight the resulting benefits. Let's begin with the introduction of the individual programs. ALLPLAN, SCIA and FRILO merge to empower and innovate the design-to-build workflow. ALLPLAN, based in Munich, Germany, SCIA, based in Hasselt, Belgium, and FRILO, located in Stuttgart, Germany, are joining forces to strengthen their delivery capabilities, drive innovation, and offer powerful end-to-end design-to-build workflows. With a strong emphasis on structural engineering, a new and combined go-to-market approach will accelerate the path to data-driven multi-material design and prefabrication, providing significant productivity benefits for customers. All 3 companies are part of the Nemetschek Group. ALLPLAN is an AEC software that allows users to plan across multiple materials and covers all areas of constructions. Furthermore, ALLPLAN provides a currently unique CDE, Common Data Environment solution with BIM Plus and the autoconverter. SCIA and FRILO are both structural analysis software programs for the calculation of simple and complex statics. The integration of these 3 programs thus represents entirely new possibilities. Next, I will now present the cloud-based Open BIM workflow between ALLPLAN, SCIA and FRILO. The Open BIM workflow begins in ALLPLAN with the creation of a 3D building model. This model is then transferred to the CDE BIM Plus via an IFC file. Additionally, the autoconverter is linked to the CDE BIM Plus, providing the structural engineering with a previously unique opportunity to participate in a BIM project. Subsequently, a consistency analysis model is imported into the structural analysis programs SCIA and FRILO via SIF, where the calculation of the building is performed. Finally, the results are transferred back to ALLPLAN via an ASF file, where the corresponding 3D reinforcement is generated based on these results. At the outset, a building model is created in ALLPLAN. I've opted for this type of hall because such constructions with columns, slabs and beams often present significant challenges when transforming from architecture to calculation programs. After modeling, the upload to BIM Plus is done via IFC. Next, let's take a brief look at the model in BIM Plus. As mentioned earlier, BIM Plus is a comprehensive CDE that allows access to model data via the web at any time. In addition to this basic function, BIM Plus offers numerous more features. For example, sections or measurements can be directly performed on the model. Creating revisions and collision checks are also possible. Furthermore, there is the option to attach specific information such as documents, comments or files the individual components to provide model-related information to all project participants. The next step involves generating a seamless analysis model through the autoconverter directly within the web application. This is also the point where in a project the structural engineer begins their work. Due to the autoconverter being directly linked to BIM+, there is no need for a re-upload of the model. The creation of the analysis model occurs in 6 steps. After selecting the model, or models from which an analysis model will be generated, the first step involves cleaning up the model. It's important to note that no elements are deleted, they are only hidden. In the following step, you can set the recognizer settings. This includes defining how individual elements, such as columns, should be recognized. Additionally, it's possible to define materials and cross-sections for components. After the elements have been derived according to the previously made settings, the alignment settings are now applied. This involves specifying the system lines as well as the eccentricities. Finally, the model is merged and aligned. It can be observed that the components have now been merged accordingly in this way. A seamless analysis model has been generated, which is now available to the structural engineering for further processing. It's also important to note that the unique component ID is retained for the respective elements. This model can now be exported in an SCIA format with the required coordination system. Before proceeding to the calculation, I would like to briefly introduce the SCIA format. SCIA, which stands for Structural Analysis Format, is based on an XML or Excel file. This makes the file very easy to edit. It also contains all the information needed for structural analysis and nothing beyond that. Additionally, SCIA is already supported by various structural analysis programs, making it an open file format as well. In the next step, the finite element method, FEM, calculation of the building is performed. This can be generated by both SCIA and FRILO. In SCIA, simply open the previously generated SCIA file. Then you can proceed directly to generating loads and defining supports. Then the building is calculated. The results of individual components, such as the slab, can now be exported in ASF format. The calculation process in FRILO follows a similar approach to the SCIA with a minimal difference. FRILO provides the BIM connector for importing building models, offering similar capabilities to the autoconverter. This allows the structural engineer to review and, if necessary, adjust their models before the calculation process. After the calculation models has been generated and prepared for further analysis, you can now choose wherever to calculate the entire building or only part of it. In this example, the slab of the ground level is once again transferred to the PLT module. In the PLT module of FRILO, loads are applied and calculations are performed. The results from the PLT are then also exported in an ASF file in case further adjustments are needed or if the construction partly does not yet comply with the static requirements. BIM Plus also offers options for revision and collaboration. There's the option on BIM Plus to directly attach the generated ASF file to the component, making it available to other project participants. Additionally, there's the option to create issues and assign them directly to the respective specialist planner. The generated issue is then also displayed in ALLPLAN, allowing for immediate revision if necessary. If all results are satisfactory, reinforcement planning can commence in ALLPLAN. For this purpose, the model is first prepared in ALLPLAN and the necessary views and sections are generated. In this case, a view from below and a longitudinal section are generated from which the respective heights are derived. Afterwards, the ASF file containing the corresponding results is imported to commence with the reinforcement planning. In this process, the FEM results are divided into X and Y directions. When reinforcement is inserted, the respective cross-section values are directly calculated with the FEM results. This way, you can immediately see where additionally layers of reinforcement would be necessary. Once the appropriated 3D reinforcement has been inserted, all possible drawings can now be driven directly from the model in conclusion. So concludes the workflow. Finally, I will summarize the results and individual steps of the workflow once again. The workflow outlined above begins in ALLPLAN with the architectural design. Subsequently, the structural engineer defines their analytic model using the autoconverter and BIM+. This model is then calculated in FRILO or SCIA. After the calculation, there is the possibility on BIM+ to locate constructive errors directly in the model using issue management. Once all issues have been resolved, 3D reinforcement planning based on the FEM results can commence in ALLPLAN. Finally, various plans can be derived from this model. In summary, from this workflow, the following advantages emerge: comprehensive solutions from architecture to analysis and detailing, collaborative coordination of details based on one model, design and engineering of reinforcement based on an integrated analysis, and it's an open BIM workflow. This concludes my presentation, pending your questions, and thanks for attention.